Hello geometry students, my name is Emigh, and this video is our discussion on section 10.2, areas of triangles and quadrilaterals with a review of perimeter. Alright, so we have four figures on the board, a square, a rectangle, a triangle, and a parallelogram. I want you to test yourself, see if you can write down the formula for the area of the square, the formula for the area of the rectangle, the formula for the area of the triangle, and the formula for the area of the parallelogram. Go ahead and pause the video and test yourself now. Welcome back. Let's see how you did. If you came up with area equals side squared for the square, you got it right. Area equals base times height for the rectangle, nice job. Area equals half the base times the height for the triangle. And last one, area equals base times height for the parallelogram. If you got all four, nice job. If you missed one, maybe the parallelogram, maybe you've seen that less frequently, no problem. Make sure you note it so that you can use it. Base times height seems to be the big theme here. Even with the square, if we called this the base and this the height, then the area would be base times height. And even the triangle, we've got base times height, but it's not that entire area. If we did have base times height, the triangle takes up exactly half of the area of that rectangle, which is why you need to either multiply by a half or divide by 2. And same thing here with the parallelogram, base times height. It's kind of tilted over if you want to think about it that way, but you can see hopefully that this space right here can fill up this space. Those are congruent triangles, and it ends up being the same formula as the area of a rectangle, which is base times height. I'll show you that by highlighting it. So it'd be this area right here. It's like you just take that red triangle and you move it from here. I'll cross it out. You move it to right here, and then you have the corresponding rectangle with the same base and the same height. That's why the formula is also base times height. Okay, let's practice finding the area of a parallelogram. Question is, what is the area of each parallelogram? We have two parallelograms here, and you know the formula, okay? We just said it. It's area equals base times height. Notice that there are multiple measures on labeled on each of these parallelograms, so be careful which ones you use as the base and which ones you use as the height, okay? So go ahead and pause this video and try to find the area of each of these parallelograms now. Welcome back. Let's see how you did. If you came up with 5 as the base and 4 as the height, then you made a good selection for this first parallelogram. If 5 is your base, then 4 would be your height. If for some reason you wanted to use the other side, the 4.5 inches as your base, then 4 would not be the corresponding height. To use this as your base, you could almost picture taking this structure and twisting it so that the 4.5 was horizontal to the ground, let's say. And then the height of that would be, it's kind of hard to see without twisting it, but the height of it would be then represented by that dashed line right there. Okay, so regardless of what you use, I think 5 and 4 were the easiest route. You multiply those together to get 20, and your units is square inches. And the reason for that is because we are talking 5 inches times 4 inches. We often leave the units off, but then at the end you have to remember that inches times inches is inches squared. One other way to think about it is we're not talking 20 linear units. We're talking 20 1-inch by 1-inch squares. Wow, those do not look like squares. 20 1-inch by 1-inch squares. Well, that's only 4, so 1 by 1, 1 by 1, 1 by 1. 20 of those 1-inch by 1-inch squares. All right, let's try the other one. If you used 2 as your base and then 3.5 as your height, nice job. It's tempting to use 4.6 as the height, but 4.6, it measures the slant. If you were to walk up to this structure and pull out a tape measure, let's say, to measure its height, you would need to go from the tallest point perpendicular to the base. So the 3.5 would be the height if you're using 2 as your base. Similarly, if you wanted to use the 4.6 as your base, you'd have to do a little bit more work. The height would be, it's hard to see if it's not actually twisted, but the height would be represented by this vertical line, right? Well, what would then be vertical if you twisted it to make the 4.6 horizontal. Regardless of what you choose, I think the 2 and the 3.5 is what most of us would do. It's just less work, and that gives us 7, and the units would be square centimeters. Okay, finding the area of a triangle. So you know the formula. It is 1/2 base times height. So go ahead and pause this video and see if you can find the area of that triangular sail. Welcome back. If you came up with, we need to make a conversion. Sorry about that. I did not spot that we were given 2 different units here. So we have our base of 13 feet, which is great, but we need to take our 4 yards and convert that to feet as well. So 4 yards, every yard is 3 feet. So it's like 4 of these 3 feet sections. So instead of using 4 yards, I'm just going to cross it out on the figure and write 12 feet instead. Okay, so now we have a base of 13 feet, a height of 12 feet. Go ahead and pause that video again if you need to and find the area of that triangle. Welcome back. If you came up with base 13, height 12, multiplying that by 1/2 or dividing it by 2, if we do our work carefully, we get 78, and that would be square feet. Here's another way to write square feet in case you don't have your exponent available. So you can write it as feet squared like that, or SQFT. Okay. Regardless, it's nice to, it's important to write those units down, but it's nice to sometimes say those units out loud to remind you that you're talking about actual squares. Okay, square feet, not linear. Area congruence postulate. If 2 polygons are congruent, then their areas are the same. All right, that makes sense. Like if I take a square and a square, let's see, these are 2 congruent squares. So let's say it's 4 by 4. So one can be mapped onto the other, or if you want to think of it as they have the same shape and same size. So if your 2 polygons are congruent, then their areas are equal or the same. Yeah, that makes sense if you can wrap your mind around that. The area addition postulate says that the area of a region is the sum of the areas of its non-overlapping parts. So what this postulate is saying, another way to simplify or restate that would be you are allowed to add together areas. Areas follow the rules of addition. For example, let's take our 2 squares that we had earlier. And that was 4 by 4. We'll add some units. 4 inches by 4 inches. That would make our first square 16 square inches, and our second square 16 square inches. And we can take 16 square inches and we can add that to the other 16 square inches. So the area, those square inches, follow the rules of addition, and that would give us 16 plus 16 is 32, and then our units remain the same, square inches, okay? And that is the rules of addition. Area follows those rules of addition. Okay. So if we're asked to find, let's do a little review of perimeter first, and then we'll get to area of this shape that doesn't have its own name, in which we have a formula for it. So we're asked to find the perimeter of this room. So perimeter is measured in linear units, not square units. So if you, let's say this is your starting point, perimeter is measured like a walking distance or a tape measure, a line. So that would be 10 feet plus 15 feet. And this is just pretend someone's walking or measuring plus another 7 feet, plus another, oh, well, how much is that? We'll get back to it. Plus another, how much is that? It's not labeled. We'll get back to it. And then how much is that there? 9 feet. So it's 9 plus 10 plus 15 plus 7. But you also walk these two distances, which they didn't tell us what they are, but we have plenty of information to figure them out. I'll start with that vertical piece right here. And the way I find that vertical length with the given information is I look at the other vertical sides. So this vertical side is 10 and this vertical side is 7. Segment addition postulate would say that this then needs to be 3 feet, so that this whole part here becomes 7 plus 3, which matches the 10 feet across the way. All right, let's go again. Let's mark this off as 3 feet. We need to find this one now. Now this is a horizontal piece, so to find its length, I'm going to look at the other horizontal sides. We've got 15 as the total side there, so this side also needs to add up to 15. Well, we have 9 already, so we would need 6 more feet for that to equal, for that side to be 15 feet total. All right, so let me erase the extra markings here and here. And so our perimeter would be 10 feet plus 9 feet plus 3 plus 6 plus 7 plus 15 feet. And the units stay feet, okay, through addition. And that gives us 50 linear feet. That would be the perimeter of that room. All right, now let's talk about a similar room that we need to find the area of it this time. So to find the area would be not necessarily walking the perimeter, like if you're trying to do like base molding or case or crown molding, that would be perimeter. But if we're talking area, that would be like, well, how much carpet do we need to cover this surface, or tile, or whatever two-dimensional material do you need? So that's area. All right, well, we don't have a formula for this shape right here, but we know that we are allowed to add areas. So if we cut this room into two shapes that we do know the formula for area of, then we can add those shapes together and get the total area. So you have some options. You could cut right here. Then it looks like you're working with a rectangle and another rectangle. You can make your cut right here maybe. Now you're working with a rectangle and another rectangle. Maybe you want to make your cut, those would probably be the easiest two, but maybe you want to add a little bit of surface area. Then you can find that total surface area and then subtract out. Remember, subtraction is just the inverse of addition. So if area follows the addition rules, it also follows the subtraction rules. So it's your choice. Cut this figure however you would like to into a couple rectangles probably, and then find the area of each and then add them back together. So pause this video and give it a try. Welcome back. Let's see how you did. So if you got 72 square feet, you got it right. Lots of different ways to get it. Well, 3 main different ways to get that. I'll go ahead and show one way, and that would be, I'm just going to cut this top part off there. Okay, so this, it kind of looks like a square, but it's not. It's a rectangle up there. So I need to find the height of that rectangle. So I know the whole thing is 8, and I know this part takes up 5, which means this would have to be 3 feet. All right. So that rectangle on the top there, that small one, is 4 times 3. So that would be 12 square feet. I like to write the 12 in the center and circle it. It's just something that I do. It means I'm saying it would take 12 square feet to fill that space. So if you want to use that, you can. Now I need to do the other space, and that space is 12 by 5. So 12 times 5 is 60 square feet. And again, I like to circle it just to remind myself that it would take 60 1 foot by 1 foot squares to tile that or to fill that surface area. All right, and then we have our 12 square feet plus our 60 square feet, and that gives us 72 square feet in the total area of that room. If you went about it a different way and you got the right answer or same answer, 72 square feet, nice job. Area of a trapezoid. The area of a trapezoid is half the product of the height and the sum of the bases. Kind of hard to picture it when you read it like that, but we'll break it down more. So what's important to know first, though, is that the height of a trapezoid is the perpendicular distance between the bases. Okay, so a trapezoid has 2 bases. Those are the parallel sides. And it has 2 legs, if you recall. So 2 sides are called bases and 2 sides are called legs in a trapezoid. The 2 parallel ones are called the bases. Okay, so if you connect or find the distance between the 2 bases, then you have found what's called the height of the trapezoid. So another way to say that is don't use one of the legs as the base, okay? All right, so the height of the trapezoid is that distance between the 2 bases. And now, I want to show you, it doesn't matter if you flipped this trapezoid the other direction. This is base, this is a base, this is a leg, this is a leg. So the height is still the distance between the 2 bases, okay? And it's the shortest distance between, hence the perpendicular marking there. Okay, so that formula now, which we had in words here, half the product of the height and the sum of the bases. So that's how you read it, but it looks like this. I also like to remember this as the average of the bases times the height. That works a little easier for me. Let me show you what that looks like. The average of the bases times the height. Go back a little. So the area is equivalent to the average of the bases. I know how to find the average of 2 things. I just add them together and I divide by 2. So when I say the average of the bases, it feels like less memorizing base 1 plus base 2 divided by 2 times the height, like that. So I just want to point out one more thing before we go on. The average of those 2 base lengths would be like this length here. There would be the length of the average of the 2 bases, and then multiplying that by the height. It's kind of, or it is, working with a rectangle again, hence the base times height part. But we have this part and this part here, which are congruent triangles with this part and this triangle here. Okay, so hopefully that didn't confuse you more. Hopefully it helps you. Area of a trapezoid can be found using this formula here, or like I said, I like to put it over 2 instead of the multiplied by 1/2. All right, the area of a rhombus or a kite. The area of a rhombus or a kite is half. Okay, so we're going to have either multiplied by half or divide by 2 again. The product of the lengths of their diagonals. Okay, let's see that in a figure. This right here is a rhombus. If you can find this length and this length, you just multiply them together, but then divide by 2, and you'll have the area of that rhombus. Same thing with the kite. Find this distance or length, find this one, multiply them together, but then divide by 2, and you will have the area of that kite. So rhombuses and kites, their formulas are the same. Their formula for their areas is the same. It's 1/2 diagonal 1 times diagonal 2. Or just one other way to see it would be diagonal 1 times diagonal 2 divided by 2. Okay, just in case multiplying by 1/2 makes you a little more hesitant to dive in and do the problem. Remember, multiplying by 1/2 is the same thing as dividing by 2. All right, so let's do an example finding the area of a trapezoid. Here we have the state of Nevada, which is approximately a trapezoid, minus out this little corner right here. but we're going to use that as a trapezoid. So our question is, what is the approximate area of the state of Nevada? Round to the nearest 100 square miles. Okay, so final answer will be in to the nearest 100, and units will be square miles. All right, so we set up our formula. Area equals 1/2 the height times the sum of the bases. And now we need to plug in lowercase h, lowercase b sub 1, and lowercase b sub 2. Okay, remember in a trapezoid to identify the parallel sides, and those will be your bases. So this one right here we can use as a base, and this one right here we can use as a base, but we need to use subscripts like sub 1 and sub 2 to identify them as different bases. And then the height would be the perpendicular distance between those two bases. So it'd be like that distance right there, or right there. So this 309, that is our height. So we need to plug those in. 309 for height, 205 for one of the bases, and 511 for another base. Then we do our arithmetic, and we get 110,622, and that will be to the nearest 100 miles. That would be 110,600 square miles. Approximately, right? So we're missing that little part right there. All right, let's practice finding the area of this trapezoid here. Okay, well, we know our formula. Whoa. Area is equivalent to 1/2 the height, b sub 1 plus b sub 2. So which of these, of the h, the b sub 1, it's h, b sub 1, and b sub 2 that we always need to plug in. These two are parallel sides. So of the markings up there, which ones of these can you easily find? Of h, b sub 1, and b sub 2? If you said 5 and 7 for the bases, nice job. We still need the height though, and it's not labeled for us. But we can't just give up. We have plenty of skills necessary to find missing parts. So I'm going to cut this end off. And the reason that strategy is going to be helpful to us is because that triangle that we cut off is a special triangle. It is a 30, 60, 90 degree triangle. So if we know one part of that triangle, we can find all the missing parts. And by one part, I mean one side length. So I can find this one. I'll give you a hint. It has something to do with the 7 and the 5 up here. So try to find this side length using that 7 and that 5 somehow. If you said that that has to be 2 meters, then you're correct. Okay? So basically taking the 7 and cutting it into 2 over there and 5 over here. So these 5s match up, and then we have the extra 2 here, giving us a total of 7 meters. Okay? I have a lot of scratch work on this page, so I'm going to erase it all and just put back up what we need. So I'm going to do this, the 2, change that to a 5. I'll go ahead and put the units on there. I'll go ahead and put H, what we're looking for. B sub 1 we already have as 5. B sub 2 we already have as 7. All right, I think that is cleaned up quite a bit. Oh, let me add this 30 degrees. We might need that. And now it's that H that we're looking for. It's the last thing we need to apply the formula. So H, I'm going to put it right there. So it looks like, or it turns out, we are looking for the side length opposite the 60-degree angle. Here's the 60-degree angle, and this would be the opposite side. So you can use trigonometry, or you can use special triangles to find the length opposite that 60-degree angle, which is the height of the trapezoid. Okay, I'm going to go ahead and use special triangles. So let me switch colors. Okay, I know that across from the 30 is S, across from the 90 is 2S, and across from the 60 is s radical 3. If you recall, my strategy is I then write an equation, and my options are 2s equals, well, I don't know what it equals, so that won't work. S radical 3 equals h. That's a good equation, but it has two unknowns in it. Third option is s equals 2 meters. That's the one I want to start with because that is my equation with only one unknown, which is s. We would then solve for s, but our equation is already solved for s, so s equals 2. So knowing the value of s in a special triangle allows us to find all three side lengths. So we are interested in h, which is equivalent to s radical 3, and s we now know is 2 meters. Multiply that by radical 3 to get the height. We did it! We have the height as 2 radical 3. We now have the three variables we need, h, b sub 1, and b sub 2, to plug into our formula and find the area of this trapezoid. So area is equal to 1/2 2 radical 3 times 7 plus 5. And if we do our arithmetic carefully there, that gives us 12 radical 3 units being square meters. If you're struggling with that, let's see, cross out or cancel the 1/2 and the 2. 5 plus 7 is 12. That might help you see that. All right, a lot of work to get through that example right there, but we have all the tools we need. So really attempt to organize your thoughts by writing down your formula. I like to then oftentimes turn my formula into a blank template, identify the blanks that we need to fill in, go for the easy ones first, like the 5 and the 7, and then go off to the side if you need to do some work to find any remaining blanks like we did for the height. Plug all those blanks into your formula, and then be careful with your arithmetic and your units. Take your time with these. It's easy to make small mistakes, but if you go slow and practice, you'll be fine. Oh, let me erase all that scratch work here. Let's say you wanted to go about finding that height using trigonometry instead. No problem. Across from the 60 is the opposite side, OPP for opposite. Adjacent to the 60 is the 2. It is tangent, which is the trigonomic function that deals with opposite and adjacent. So that would be tangent of 60 degrees is equal to h over 2, opposite over adjacent. We could then isolate h, so multiply both sides by 2. So that would be 2 tangent 60 equals h. And so this right here, this 2 tangent 60 is the height. So that would be, if you had used trig instead, your height would be plugged in as 2 tangent 60. It's kind of nice to see that 2 radical 3, when we use special triangles, is our height, and 2 tangent 60 is our height if we use trigonometry, which means, we haven't really discussed this yet, but 2 radical 3 would have to be equivalent to 2 tangent 60. Cancel out the 2's even, and we would have to, that means that radical 3 is equivalent to tangent of 60 degrees. We haven't got into that yet, but nice to see that right there. Okay, let's find the area of this kite. Do you remember the formula for the area of a kite? If you said diagonal 1 times diagonal 2 divided by 2 or multiplied by 1/2, you got it right. All right, we need to find the lengths of our diagonals now. So this is one diagonal, segment LN, and this is our other one, segment KM. Length of LN is 6, and length of KM is 7. Segment addition postulate. 3 plus 3 is 6, that's where we got that from. And 2 plus 5 is 7, that's where we got that from. Now we do 7 times 6, multiply by 1/2 in some order, and we get 21. Unit is square meters. That will conclude our discussion on section 10.2. My name is Emigh. Thank you for joining me, and I will see you next time for our discussion on section 10.3.